Hello everyone, today we are going to work on this detection indicator you can see here in the screen. So here is a demonstration again. There is one enemy behind this wall and there is another enemy behind this wall. When I go into the visible area of those enemies, you start to see this detection indicators. Once I'm fully detected, the icons blink and disappear. So at the moment I haven't connected their logic to start shooting at me because I just want to demonstrate this detection part. So that's what I'm going to work on today. Right, so yesterday we worked on this UI component. Where is it? Here, detection meter. So now I'm going to actually use it inside the enemy AI character and show up when they start detecting the player. By default this should be transparent a bit. It should not be filled initially. Okay, so how should we integrate this into AI enemy characters? So for that, let's go to the location where I have implemented enemy AI characters and AI is here. Here are the EQs, environment queries and behavior trees and everything is here. So let me open ALS AI controller. And yeah, this is hearing. Here is the site. Here on Z. Okay. So here first this detection indicator should appear only for the player character. It doesn't make sense to show a detection meter and the UI when an AI character detects another AI. So here let's we need a branch is player. This is target is an actor. So I have implemented this 𝐶LMBPI is player function in 𝐶LMBPI character. If you don't remember it, let me show you. Here, this is ALS base character and we have is enemy. Sorry, is player, this one, and it simply returns the value of is player controlled. So for the player it would be true. So now here if it is player, well, we need a branch. First, this should not be applied for ally characters even if it is a player, so I'll put it after this. So if the target character is not the player, we can take the usual path. Otherwise if it is the player, let's take another path. Here let me just add a print just player detected yeah, detected wait, we have this detected parameter also, so let's have two things using this branch. Player detected. I'll make this red and keep for 10 seconds so that I can easily notice this when printed into the screen. Then I'll add again player lost. Wait, let me put this guy a bit closer so that it is easier for me to test. Okay, player detected that, and player lost. Player detected, player lost. Great. So those are the two things I need in order to implement detection meta. Again, this part is not needed. Here, let's do something like this. I'll add a variable player detection level. This should be a float, and by default it should be 0. It is. Then wait, not necessary for this to be 0. Let's make it an integer so that we can increment it easily like this. So here player, let me get rid of this text. Let's do it like this. When we see the player, let's increment this player detection level and have a delay. Maybe point, we can change the delay amount. Have a branch. If the detection level is less than, let's say 100, well, if I say 100, then it would take 2.2 by 100 20 seconds, so that's too much. Let's say 20, so 1 second, or maybe 42 seconds to detect. So if this is true, that means player is detected. Otherwise we will have to go back. But here we need another condition to check if we still see the player. So let's add another boolean. Player see, no, player visible. That should be a boolean. And here I'll set this to true. And here I'll set this to false. Shall we collapse this part to make things simpler? Player detection. Right. Now here I should continue this iteration only if let me add a once node here and break it after this, just to prevent calling this multiple times, and do a check. To see if enemy is still visible. Sorry, player is still visible. If the player is not visible, we should decrement this value. And if this value is less than 1, that means 0, then if this is true, that means we have lost the player completely. Otherwise, we have to go back and loop again. Oh wait, we should have a delay just like here. So yeah, as I said, if this is true, then we should print player detected. So that means player fully detected. And here I should print player lost. Right, so now let's see. Wait, why did I instantly get player lost? Okay, detected. Oh, sorry, this should be the other way around, larger than 40. So when I go into the view of the enemies, it should take some time to see player detected. Why am I not seeing? Okay, I got it. Player detected. Now if I go out, oh, I wouldn't get player detected because this loop is already completed. So to see the progress, here let's add a print. Where should I add it? maybe before this. Yeah, sorry, print string append detection level okay. Now we need to connect these execution pins here. Right, now I should see the detection value rising. See, once it go over 40 I should get detected, and when I go out of the player's view, enemy's view, see, it's losing. Okay, right, so now the next step is, once we start detecting the player, let's start showing that widget we created. So I'm not sure if this is the best place to create a widget and add it to the viewport, but for now, just for testing and keep things simple, I'll create widget. I'll just create the widget here. From the class detection indicator, promote it to a variable WTG detection. And yeah, add to viewport. So once when the player either fully detected or lost, we can get the widget, remove from parent. So we still have to connect these when the player is detected or lost. We still have to connect these into relevant places, like here, update target actor or remove target actor, things like that we still have to do. But for now, let's just make the widget work. So now I should start seeing the widget. See, I get the widget, and it doesn't rotate or anything to match the direction of the widget disappeared. It doesn't rotate or anything still to match the direction of the enemy. Let's go into that part in a bit. So first, let's update the widget detection level. Shall we promote this 40 and variable detection detected level, right? That makes sense. Detected level. Okay, now in this widget we need to have a value in between 0 and 1 to fill the progress bar. So how should we do it? Let me collapse this. Create detection widget. Right, and here we get some space. Collapse again. Update detection UI. Right, now get the detection widget and set what's the function name? Update percent. Update percent. With the current detection level divided by detected level. So this one divided by this one, it returns an actually integer, so that's not the way I need it. We need to have a float value. Convert to float. Right, now we should see the bar fills. See, it's filling, and if I go out, it's reducing. So now you can see it fills in steps. So if I want to make it smoother, we can do something like this. Make this a smaller value, but then the detection speed would be faster, but we can adjust the max detection level, detected level, to compensate for that. Okay, if I make it even smoother, we can have 0.05, and detected level instead of 40, I'll make it 80. Oh, why not 100? Now it's much smoother. Okay, now the next step is how to make that detection meter blink when it reach a certain value. So actually when fully detected, not reached by a certain value, when it's fully detected. So that means here detection blink. Oh, here we don't have a way to turn it off, but toggle blink, all it does is just me rename this, just blink. Blink icon. Okay, it will play the blinking animation. Let's keep it for half a second before we remove the icon. So let's see. When it's fully filled, it should blink. Oh, and it went away. Maybe we should do it in a different way. Yeah, instead of blinking here, can we stop this animation? Yeah, but stopping, no, let's use the previous way. Let's keep it for 2 seconds. Blink. Okay, and went away. Maybe the animation could be a bit faster. 3. Let's see. And also, to test it faster, let me change the detected level back to 50 so that it will be filled fast. Okay, so let's reduce to 1.5. Alright, now the next step is making this icon always point to the enemy. So here now it's not actually pointing to the enemy. So to do that, we need to update this angle based on the direction player looking at and the direction the enemy character is. So how to do that? I think we should update that in the event tick. Do we have a tick here? No. So let's add one, because the rotating of the icon should happen in real time. We can't have a lag there. Okay, here if we have a widget detection, let's convert this to a validated get. Then we need to update angle. So how do we calculate the angle? So we can get the direction player is looking at using get player controller and get control rotation, and then we can get the direction or rotation to the from the player to this enemy who is who possesses this AI controller instance from this method, get player character, get actor location, and then get controlled pawn to get the location of and get actor location. Sorry, get actor location. This will give us the location of the character that is in control that is controlled by this AI instance. Then we can find locate rotation from the player to this character. Then if I get the delta of these two rotations, I should get the rotation value we need for here. Then here if we only consider the yaw, that should do it. Let's see. See, it is rotating, but it's not exactly correct. Yeah, it's rotating in the wrong direction, I think. What if these two interchanged? Correct. Okay, maybe it would be better if I increase this distance. Where? It didn't do anything. Okay. Yeah, actually just increasing this is not enough. Let me make it 15 and also move up this one above here maybe minus 300. Then if I change the angle, you see it's rotating in a higher with the higher radius. If this is still not enough, we can further change this. Maybe not that much. Right, I think that should be enough. Right, let's test it. See, I am getting it. Okay, so if I add another enemy, maybe this enemy here, I should get 2 detection meters, 1 and 2. See, both are working independently. So yeah, so I am going to stop this episode right here, but still we have to do a lot more stuff to actually connect. After the detection bar is full, we need to update the AI behavior tree to actually start shooting at the player. But since it has taken over 30 minutes, I'm going to stop this episode right here. So let's look into those things in the next episode. And thanks for watching. As always, project files will be available here for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.